You know, we're living through two of the biggest revolutions of our time, all at once. The absolute explosion of artificial intelligence and the massive global shift to renewable energy. But what's really wild is how these two worlds are connected, and it's not in the way you might think. So let's dive into this double-edged sword, and it all starts with one, frankly, mind-boggling number. Okay, get ready for this. 945 terawatt hours. It's a number so big it's almost meaningless on its own. So, what in the world is that? Well, that's what experts think AI data centers are going to need every single year by 2030. Turns out the brain behind this AI revolution, it is incredibly thirsty for power. See, training these huge models, the ones running everything from your chatbot to those wild image generators, takes a ton of computing power, with thousands of specialized chips just humming away 24/7. But to really wrap your head around just how massive that is, you need some context. Yeah, check this out. By 2030, AI alone is on track to slurp up more electricity than the entire country of Japan does right now. That is a huge new weight to drop on our power systems, which, let me tell you, brings us to our first major problem. So, why is this new demand such a massive issue? Well, the thing is, this massive demand is hitting our power grids at the worst possible time, right when they're in the middle of their own, let's call it a chaotic makeover. So here's the heart of the problem. As we try to do the right thing and move over to renewables like wind and solar, our electricity supply is becoming way more volatile and, frankly, a lot harder to predict. And this graph right here, it tells a really important story about the money side of the grid. Basically, what happens is when you lose a renewable source, like poof, the wind just stops blowing, the price of electricity can just go through the roof. That kind of volatility makes it incredibly tough for the people running the grid to keep things stable and, affordable. I mean, just think about how different things used to be. In the old days, the grid was simple, right? It was powered by stuff you could just turn on. Need more power? Burn more coal. Easy. But now we're leaning on the weather. And as we all know, you can't just ask the sun to shine brighter on demand. Okay, so let's recap. We've got AI creating this monster energy demand, and at the same time, our grids are getting shaky because of renewables. It really feels like we're heading for a crash, right? But, and this is where the story gets really interesting. What if AI isn't just the problem? What if it's also the key to the solution? No, really, think about that. The very same technology that's creating this mess, could it also be the thing that cleans it up? That's the crazy paradox we're diving into right now. And the answer starts with this idea of a smart grid. Now, this isn't just your grandfather's grid with a fresh coat of paint. We're talking about a fully digitized, intelligent network that can manage the wild, chaotic flow of modern energy in real time. And believe me, this is a total game changer. We're going from a simple one-way street, power plant to your house, to this complex, multi-lane highway of energy. Power comes from everywhere, the supply is always changing, and you're not just a customer anymore. If you've got solar panels on your roof or an EV in the garage, you're what they call a prosumer. You can produce and sell energy back. You're part of the system. Okay, so how does AI actually wrangle all this complexity? Let's pull back the curtain and see how it's being put to work to optimize this new intelligent grid. A lot of the time, the magic ingredient here is something called reinforcement learning, or RL for short. The easiest way to think about it is to imagine an AI that's like a genius-level day trader, but for energy. It learns by doing, trying things out, getting rewards for good moves and penalties for bad ones. It runs millions and millions of simulations, basically learning from its mistakes until it becomes the perfect energy manager. So what does that learning process look like in practice? It's this constant four-step dance. First, the AI observes everything. What's the price? What's the weather? How much power are people using? Then it acts. Maybe it tells a giant battery to start charging because power is super cheap. Third, it gets a reward. Hey, you saved a ton of money. And finally, and this is the most important part, it learns from that reward to do an even better job the next time around. So what does this AI actually do in the real world? This isn't just theory. Okay, picture this. It's a scorching hot day and everyone cranks up their AC at the exact same time. The grid is screaming for mercy. Instead of a blackout, an AI can send a tiny invisible signal to thousands of smart thermostats, asking them to adjust by just 1 degree. You wouldn't even notice. But altogether, that tiny change saves a massive amount of power and keeps the grid from crashing. That's AI in action.
And believe it or not, that's just the beginning. The grid of the future is going to be even more intelligent. But it also comes with a whole new set of problems we absolutely have to solve. I mean, the next wave of tech is already knocking on the door. Then you've got this amazing idea called vehicle-to-grid, or V2G. This could be a total game changer. Imagine millions of electric cars, all plugged in, acting like one giant, city-sized battery. When the grid needs a little extra juice, they can send power back to it, stabilizing the whole system. It's incredible.
But there's a catch, of course, a big one. The smarter and more connected our grid gets, the more doors and windows we open up for hackers. We're essentially creating a bigger target. And here's the final twist in the story. AI might be part of the vulnerability, but it's also our best security guard. We're basically in an AI arms race. You've got bad AI trying to hack the system, and good AI playing defense, predicting attacks before they even happen, and stress testing our own systems to find the weak spots. So that brings us full circle, right back to that central conflict. AI's hunger for power is enormous, maybe even dangerous. But at the same time, it's giving us the brains we need to manage a green, sustainable energy future. The real question, the one that's going to define the next few decades, is which side of AI is going to win? Will its intelligence evolve faster than its appetite?
This is for entertainment purposes only.